Alright gang, on to chapter 4. Honestly, this chapter, you should be able to do it in about an hour if you read through it, half an hour, 15 minutes, because if you've taken any other programming language, you already know what an if statement is. You probably already know what and, or, and not mean. If all you've taken is Python, then you've never seen a switch statement before. That'll be new. If all you've taken is Python, and then you won't have seen a do loop, but you certainly have seen a for loop. You've certainly seen a while loop. Anyways, we got to do it due justice. But a lot of these concepts are going to seem familiar. How about an if statement? An if statement looks like this, right? I had to zoom in like that. Anyways, right? If something, do something else, right? So for example, right, if x equals y, then system.out.print something, right? Or if name dot equals parentheses quote Bob, end quote, in parentheses, then print hello Bob, right? That kind of thing. I'm sure that we've already demonstrated a couple of if statements in our prior lectures. And you know from any other programming language what an if statement is. If you don't, you have the keyword if. In this particular language, you have to have parentheses, unlike Python. Then you put up what's known as a Boolean expression there. They're calling this a condition, right? That's the condition that causes the if statement to trigger. And if this expression evaluates to true, if x really is equal to 3, then it will do whatever's within the curly braces. Then there's the while loop. Does much the same thing, does almost the exact same thing, with a key difference. Again, you have your condition, right? While x is equal to 3. But once it gets to the bottom brace, it doesn't just keep going. It jumps back up and it checks the condition again. And if the condition is still true, it repeats the body of code, right? So if you're going to do that, something had better change x, or else it's never going to be able to get out of the loop. Unless there is a return or a break statement inside the while loop, right? Because if you can break out of the while loop, it's okay for this to be true all the time, for nothing to ever change x, right? Or, you know, if you can return or break out of it, otherwise, something has to modify the x value, or else this will never become false and it'll not exit the loop. And if this is false to begin with, it doesn't go into the loop. It won't do whatever's here. Typically, each condition involves some type of comparison, and the comparisons use comparison operators. What are comparison operators? Like equal, or less than, or greater than equal, or not equal, that kind of thing, right? You will see one variant, which is while true. What does that mean? It means do this as an infinite loop. Keep repeating it forever. Well, why would you write an infinite loop? Because you're probably going to have a break statement in here that'll let it exit under a certain condition. Well, why didn't you put that condition up here? It just makes it easier to construct the loop logic. And we'll hit a case or two where we want to write while true loops. I just want you to get used to the idea that that is one way of writing a loop, is to have a while true and then have some kind of case down here, like if, you know, answer, you know, or choice dot equals parentheses quote quit, right? Because they want to quit, then you can break out of the loop, right? If I can spell break correctly, right? That lets you get out of it. You might have more than one break, right? If error, then break. If the user enters a 0, break, right? And instead of break, if you're inside a method, you know, a function in other languages, then you might have a return, which causes it to exit the loop. So the comparison operators, equal, if x is equal to 3, right? Not equal, if x is not equal to y. If x is in fact not equal to y, then this evaluates to true. So you could say if x not equal y, print not equal, and it would in fact print that. Less than, greater than, less than or equal to, greater than or equal to. I'm pretty sure that you get those in grade school or middle school or whatever. You know what those mean. And each comparison operator evaluates to either true or false. Each one is also known as a binary operator, meaning it requires something on both sides, right? You have to put something on both sides. It has to have two so-called operands. Here, x and y are the operands. The operands are just the pieces of data on the left and right side, both of which are necessary for a comparison operator to work. Because if you didn't have something on the right side, what's it going to compare it to? You know, if x is greater than equal, right? Had to have two things. That's all binary operator means. It doesn't mean that it's full of zeros and ones, although ultimately everything in a computer is. It means that it needs to do a comparison. We've seen binary operators before. If you do x equals 3 plus 4, that arithmetic operator is a binary operator because it requires two operands, piece of data on each side. All right, so there we go. We know what those are. We know what equal equal does. You have to use two equals if you're inside of an if for a while. Otherwise, it just tries to copy the value into the variable. The compiler won't even allow that in this language. In some languages it will, and usually that's an error. So it's a good thing that Java does not allow that. So 3 equal equal 3, that certainly is true, right? 3 equal equal 4, that's certainly false. Normally you're not going to be comparing numbers like that. Instead you'll be comparing variables to numbers or variables to variables, right? And then there's not equal. Not equal is just the opposite, right? If we did this, x not equal to y, well, if x and y are both equal to 3, then that would be false, right? Because 3 not equal to 3, that expression would be true. If 3 not equal 3, then do something, well, it's false. If it said, if 3 equals 3, like it says up here, then that's true. But 3 not equal 3 would certainly evaluate to false. Let me undo my changes here. Less than, greater than, etc. work as expected. Use an if statement if you need to ask a question. The phrase ask a question sounds a little bit silly. In order to determine what to do next. In other words, if the program needs to make a decision. If it needs to do something or nothing. Or if you need to do something or something else. If you have an if without an else, it does something or nothing, right? If raining, stay out. If raining, wear a raincoat. We're not even going to tell them what to do if it's not raining, right? If x equals 3, print, wow, x equals 3, right? We're not going to print anything else. That's just an if by itself. What lecture are we on anyways? Looks like we're on G. All right. Lecture H. Is that really the case? Pardon me. Yes, that is the case. All right. So you know the drill. If, let's create a variable called temperature, right? If temp, we need to have that variable declared, right? So double temp is equal to, it's a balmy 70 degrees outside. If the temperature is greater than 100, it's too hot, right? So if temp greater than 100, system.out.println parentheses, it's too hot. In fundamentals of programming, that was called a single alternative decision, right? Because you either do something or nothing. The something is the case when that's true. And then that textbook had a fancy word for what it did if this was not true, which was the null case. Null meaning it just doesn't do anything. All right, then there's another version of it, the dual alternative with else. If the temperature is less than 32 in parentheses, we're going to print something, right? System.out.println parentheses. Water is freezing, right? Because it's below freezing. Else, what are we going to say? System.out.println parentheses quote. Water is not freezing, right, because it's above 32 degrees. And I never can remember if freezing point is less than 32 or less than or equal. I think it's less than or equal, so there we go. All right, what if we're going to do 3 steps or 4 steps or 5 steps? You can chain ifs and elses. Some people call it an if cascade. I'm not going to really show why, I don't think. If the temperature is greater than or equal to 212, which is the boiling point of water, under standard conditions, 1 atmosphere, then system.out.println parentheses, water is, how about we just say, water equals gas, right? Because it turned into a gas. Else, if, parentheses, the temperature is less than or equal to 32, in parentheses, we're going to print that the water is a solid. System.out.println parentheses, water equals a solid. In quote, in parentheses, semicolon. Else, system.out.println, and if it's not a gas and it's not a solid, the third case is that it's a liquid, right? Water equals liquid. Semicolon. Make the error go away. What if the expression needs to be a little bit more complex, right? What if the expression depends on 2 things, not just 1? How's about this? Boolean hungry equals false. No. Let's make hungry an actual variable, right? You're playing The Sims and your character is hungry. So int hunger equals some value between 1 and 10. Our dude is really hungry. He's got a hunger of 10. And then int money equals, he's only got $3 in his pocket. So now we're going to make a statement. If hunger is greater than 5, he has to be pretty hungry. And that's what the double ampersands mean, the shift 7. And money is greater than 5, you have to have more than $5 to go out and eat anymore. Then system.out.println, go out for dinner, in parentheses and semicolon, right? Else, we're going to print stay home, right? Hope that makes sense, right? If our hunger is high enough and our money is high enough, then we're golden. We get to go out to eat. If not, we're going to stay home. How about we do something else? Int sick, our sickness level, we're perfectly healthy. If our tired level is really high though, right? And so if sick is greater than 0, right, even if you're a little bit sick, or that's the shift backslash, the shift of the key above the enter key, shift backslash 2 vertical bars, or tired is greater than 8, right? You have to be really tired or just a little bit sick to get to stay home, right? So system.out.println parentheses quote stay home exclamation mark, end quote, in parentheses semicolon. I don't know why sometimes I'm putting the curly braces and sometimes I'm not, right? Else system.out.println parentheses go to work, right? So we only stay home when we're super tired or we're even a little bit sick. If we're a little bit sick, we don't want to go there and get everybody else sick. Now I know if we're a little bit sick, we usually go to work anyways, but let's pretend. Hope that makes sense. Ampersand, ampersand means and means both sides. Both operands, technically speaking, have to be true. Now these expressions could either be expressions like that or they could simply be Boolean variables. What do I mean by that? Well, what if we have some Boolean variable that is called error state, right? It's either true or false. And we have another Boolean variable called, I don't know, out of disk. Okay, we're going to change error state to out of memory. And then we're going to change out of disk, right? Here we go. So we have two Boolean variables. Out of memory, out of disk. And if out of memory or out of disk space, then print like that. That makes sense, right? That means or means only one side or the other have to be true, not both of them. We only are going to print oh no under one of these conditions. Either one of these conditions is enough to trigger the oh no message. So why did I call that an if cascade a little bit earlier? A whole chain of if else's. Because you could make it look like this, right? Let's declare a string called state, or heck, grade, right? And let's declare another one called score, right? And our score may be 85 out of 100. So if, parentheses, score greater than or equal to 90, in parentheses, then grade equals, quote, A, end quote, right? Because I earned an A. Else, now normally we would use else if, right? But just for this case, just for this example, I'm doing it a little bit differently. If score is greater than or equal to 80, in parentheses, then the grade equals a B, right? And we can keep going all the way down, right? Make a C, make a D, make an E, make an F. But maybe that's proving the point here, right? Because you see that this is indented one level, this is indented two levels, and if we were going to keep going, right, like if you don't make an A or a B, you're going to fail. That's one harsh teacher, right? But we could have tacked on something else here, right? Else if score is greater than or equal to 70, then you make a C. But the way we phrase these up here is not with else if, but with else open block, right? So what is a cascade? It's a series of waterfalls. That's the technical definition of a cascade, you know. Or if you have a cascade of errors, that means you have one problem after another. Well, look what's going on in here. We have waterfall shape, right? A, B, and C. Fortunately, we have else if, so we don't have to construct these things like that. We could just do it like that. And I would have to format everything correctly, right? Which I am not taking the time to do. But now you get it, right? It's the same thing. It's just not a cascade anymore, right? But you could still call it a cascade because it's, you know, kind of a tree of if statements. It's one after the other after the other. Here's a common mistake, or at least something to think about. When do you use else and when not? Would the program work just as well if this was just else? Excuse me, if you took out the ifs. And the answer is no, it would not work just as well. Right? Grade is 85. If this, excuse me, score is equals 85. Is that greater than 90? Great, it's not an A. Too bad. Okay, let's come down here. Is score greater than equal to 80? Yes, it sure is. So our grade is a B. Then we skip down here. Is that score greater than 70? It sure is. So now we're making a C. Yeah, but we already had a value for B. Right, we're triggering multiple here. We triggered that one and triggered that one because we did not have else. Put an else there, and now we're feeling good. Now it's working okay. Now maybe sometimes you want multiple things to happen, right? We did up here, right, because we wanted to go out for dinner or stay home. We would not have put an else here, right, because that is completely different. But here, all of this stuff is dependent upon that variable. That leads us to the idea of a switch statement. A switch statement lets you pick among different cases. It's a replacement for an if cascade. What do I mean by that? Well, what if I had some little program that asked me for the size of a sphere, and based on that sphere size, I set a variable called diameter. And so I'm going to create a variable called diameter. And I'm going to create a string called choice, right? Because they're going to make a sphere size choice. So system.out.println, parentheses in parentheses. We need to tell them what we need to type, right? 1 for marble, 2 for grapefruit, right? These are 2 different sizes that our sphere might be. And then we need to read it in. So we're going to need a scanner and all that. I'm going to skip that, right? You know how to do the scanner. And so choice equals, and say they picked grapefruit. What if we had a third choice, basketball? Kind of almost need to start that on a new line, right? But you know what that looks like over there on this side. Alright, so the choice not equal to 2 without quotes. I guess it could be, right? Scan the input for an int, in which case string choice would need to be an int, right? So scan the input for an int. Now we could do this. If the choice is equal to 1, then the diameter is equal to whatever the diameter of a marble usually is. Let's say 0.5. I have more specific values somewhere else, right? But if choice equals 1, now it's complaining because I haven't actually set the value, right? I did not do choice equals scanner.next int. Yeah, I probably ought to just include the scanner, for fun and actually make it work. Let's do that. It's not much more work. Scanner sc equals new scanner, parentheses, system.in, in parentheses, semicolon. Now we can read it in, right? So choice equals sc.nextInt. It doesn't know what a scanner is because I haven't included java.util up here. But I'm going to let netbeans fix that for me. I'm just going to click on the little error and say add the import. All right, now we're good. Right, we've asked them for the size. If the choice was 1, the diameter of the sphere is 0.5. Else, if parentheses choice equals 2, right? Let's say that's a marble. Let's say this is the grapefruit, just to remind ourselves. And there's probably more elegant ways of doing it than this, but let's just roll with it. Well, what's the diameter? Alrighty, so if diameter was measured in feet, right, then that marble is a heck of a lot smaller than that. Let's say that a marble is 0.10 of a foot, right? That's still not right because that's like 1.2 inches, but let's just go with it. But if it's a grapefruit, its diameter is a little bit large. Let's say that a grapefruit is half a foot wide. That's a great big grapefruit, whatever. And then else if the choice is equal to 3, then it was a basketball, right? So we're going to set the diameter equal to, a basketball is, 0.9 of a foot. Let's just say that. So yes, diameter is feet, and I'm just going to put, feet here to remind myself, and, feet here to remind myself of the units. Feet here to remind myself of the units. And I could have actually called this diameter in feet, right? I could refactor it to give it a better variable name, but I'm just going to leave it like that. Okay. And I'm going to do a little bit different, just to keep this on the screen. Well, you know what we probably ought to do is, if none of the above choices were true, we should tell them that, right? Because they typed in something other than 1, 2, or 3. So if they choose something else, we're going to tell them invalid choice, defaulting diameter to 1 foot, right? In quote, in parentheses, semicolon. And let's do that. Diameter is equal to 1.0 semicolon feet. Okay, that's a catch-all. This is a catch-all else. Even if we thought that there was no possible way that choice could be nothing other than 1, 2, or 3, it's not a bad idea to have a catch-all else at the bottom anyways. Just to make sure, right? Something unexpected could have happened and it gave us a different choice than 1, 2, or 3. So it's always a good idea to have a dangling else, a catch-all else. Okay, so that's one way of writing that. We could do something with that choice now, right? We could print out the diameter or something. System.out.printf, parentheses, quote. Diameter of sphere is %.2f, 3f, how many decimal places do we want? %.3f, feet, \n, end quote, comma, diameter, right? And I forgot to type the f even though I said it, printf. All right, let's run it, see how it's working. Check our output. Do we want a marble, a grapefruit, or a basketball? I want a basketball. The diameter of the basketball is 0.9 feet. All right, now I'm going to give you a homework assignment, and it's going to have diameters that I actually want you to use. So then, this is like an if cascade, right? Notice this little warning up here. It says convert the ifs to a switch statement. I'm going to go ahead and do that. Then I'll probably undo it for the case of the lecture, but here we go. Here's the way it works now. It says switch voice. And just like a switch can have multiple positions, right? You might have a dial that's, set your input from, your PlayStation, and then your VCR, and then your cable box, and then your TiVo, and your this, that, and the other, right? And the different switch positions do different things. If choice is a 1, case 1, then set the diameter equal to that. Then break. That break keyword is extremely important. The break keyword means exit the switch. If you don't have the break statement, it's going to run down here and it's also going to set it to that. So if I commented out the break here, then if the case was 1, it would set the diameter equal to that, and then it would so-called fall through and also set the diameter equal to that. Do not leave the breaks off unless you absolutely positively mean to. If your code depends upon the breaks being absent, at least comment it and do fall through, right? Add that comment there so that somebody else who comes and looks at your code will understand that no, it's not just that you were a dummy and left the break off. You really intended it to go through to the next statement. But that's not the case here, right? So if the case was 2, it's the grapefruit, 0.5 feet. Case 3 was the basketball. Now some people like to put the curly braces here, right? Like that. Case 1, curly brace, that. Case 2, curly brace, that. Case 3, curly brace, that. Now why might you want to do that? Well, if you declare variables in one of these cases, I don't know why we would here, but we want to set x equal to 4 inside there. Since this is declared within these braces, it's not available to the other cases, which may be a good thing, right? So if you have variables that you want to declare inside a specific case, you probably ought to put it in the curly braces like that. But they're not necessary. Okay, so I'm going to undo this so that it's back to the way it originally was. Gee, a lot of undoing. Kind of wish I just copied and pasted. Okay, that's back to our original code. Now, let's ask them for a material. Like whether something is ice or whether something, okay, let's say whether it's made out of balsa wood or whether it's made out of gold. So let's print that choice out. System.out.println, parentheses, quote, 1 equals balsa wood, 2 equals gold, end quote, in parentheses. Now let's let them type in a new variable, or we could just reuse the same one, I guess. Choice equals sc.next int, parentheses, in parentheses, right? Now instead of doing if, instead we're going to do cases. So, switch, if I could spell, switch based on the choice, in parentheses. What are our choices? 1 and 2. Those are the only choices we have right now. So case 1, and if that was chosen, then we're going to set the density of our material. Well, we need a density variable. So double density equals 0, right, whatever. Maybe I should put that up here along with my other variable declaration. So I'm going to cut that one out, come up here and paste it. And there we go, right? And by the way, where are we going with this? We're going to be calculating the volume, and we're going to be calculating the mass. That's where this is totally going. So I'm going to add those variables as well. So the density is in pound per cubic foot. The volume is in cubic feet. Let's just say cubic feet. And then the mass is in pounds. Okay. So we've kind of declared our variables. I may not even put a comment on choice. I probably ought to. I'm going to put it down here underneath everything. Okay, so here we go. We've asked for the material, but we haven't made any decisions yet. So case 1, the density of this is like 0.1. Balsa wood's very light. Great. Case 2, they chose gold. The density of gold is like 1,203 pounds per cubic foot. Gold is very heavy. You know those games where you find a chest full of gold? If it was a big chest, it'd be absolutely impossible to move because a single cubic foot is 1,200 pounds. 2 cubic feet of gold is, is 2,400 pounds. So 2 cubic feet is more than a ton. Gold you would not carry around, in a backpack like that, a cubic foot of it. Anyways, all right, so we have to break out of that. Now, what if they didn't make any valid choices? What if they typed in 3 or 0 or something like that? Well, that's what this handled up here, right? Our else statement. Scroll down here. Default. This is the default case. If they didn't make a correct choice, we're going to yell at them and set the density equal to 1. System.out.println, parentheses, quote, invalid choice. Default density is 1 pound per cubic foot, right? However you want to write that. Okay. So there we go, right? System.out.println, invalid choice. Default density is 1 foot. And let's actually do that, right? So the density is 1. So now we have the diameter. Now we have the density. We can actually perform the rest of the calculations now, right? Calculate the volume, which is equal to about, 4.0 divided, when I say about, I mean this is the equation for it. 4/3 times pi, right, times radius cubed. Well, we don't have the radius, do we? All we have is the diameter. So we might want to create a variable called radius, right? Which is just equal to the diameter squared. Excuse me, diameter cut in half. That's what a radius is, right? It's half the diameter. So we're going to calculate the volume as that expression. Then we're going to calculate the mass. Calculate the mass as density times volume. Excuse me. Yeah, that's correct, right? Mass is equal to density times volume. So if you have 2 cubic feet and it weighs, 1 pound per cubic feet, then it's going to weigh 2 pounds. And then display the results. That's what the program needs to do. So here's what the homework really is, right? Going to prompt the user with a menu of sizes. Marble, golf ball, baseball, basketball. Looks like I left out grapefruit, but I didn't know what grapefruit was anyways. Beach ball and one of those great big exercise balls. The diameter in feet of a marble is 0.5. The diameter in feet of a golf ball is 0.14. Basketball is 0.8, right? So I guess I could go back and modify my code with those actual, more realistic values, if I so chose. And I do. So what was it for a marble? A marble is, oh, see, I just got twice as large as it really was, right? 0.05. And what was it for a basketball? 0.8. Not too far. Right, and grapefruit. If you feel like throwing grapefruit in, go ahead and, pick a size for it or whatever. But that's not one of the listed values that you have to implement. Then the densities, right? Here are the densities you need to support. Now, I didn't put balsa in here. If you feel like Googling up the density of balsa wood in pounds per cubic feet, probably wouldn't take you too long to do that. Balsa density in pounds cubic feet. Balsa blocks weigh about 8 to 16 pounds per cubic feet. Well, what about water density? What's the density of water in pounds per cubic feet? Oh great, why didn't it just blip into an easy answer? Forget it. Anyways, it's pretty close to ice, right? Because ice is a little bit less dense than water, which is why it floats. And so that 8 pounds per cubic foot would make it a very floaty thing, even more than ice. So down here where we said balsa wood, we could make our choice equal to 8, right? Because 8 pounds per cubic foot. Whatever. Pounds per cubic foot. Same comment here. Pounds per cubic foot. Now, just because I said that 1 was a marble, 2 is a grapefruit, 3 is a basketball, or whatever, notice I don't specify the choices. And I don't specify even, what you call them. Whatever numbers you want to assign to these, or however you want to split them up, that's totally fine. But you're going to let the user specify a size. You're going to let the user specify a material. And then it's going to calculate density. Excuse me. It's going to calculate volume based on that. And it's going to calculate the mass. I don't know why I said weight. Weight is a very imprecise term, where mass is a very precise term.
Well, the name's familiar. I don't remember about...
I should just do a search and replace on this document and replace every occurrence of the word weight with mass. I'll do that. Anyways, that's what it's supposed to do. So, for example, you've already seen how it works in our code, but choose a material of sphere. Ice, aluminum, or gold. And then choose the size of the sphere. Marble, golf ball, or baseball. The density of the object is that, because they chose gold. The radius is that. The volume is that, and the weight of that is that. So if you had a golf ball, if you had a baseball made out of gold, it'd be pretty heavy. It'd be 72 pounds. I'm not quite convinced that that's accurate. We're going to do a little bit of research here. Make sure that's correct. So a baseball is 0.24. So let's do volume of sphere. And let's type in 0.24, right? So that's our radius, 0.24. And if volume is equal to 4/3 pi r cubed, let's type that in. 4 divided by 3 times pi, which I'm going to just pretend is 3.1, times that volume that we saw down here, 0.058. But that has to be cubed, right? So I'm just going to multiply it by itself 3 times. I'm just eyeballing this to make sure that my document had a correct value for it. And so that would have been the volume, and if we had multiplied that by 1200 per cubic foot. Okay, I'm not validating it correctly. I will go back and make sure that this example up here is correct. You ought to be able to write the program without it even being correct, but I'd like for it to be correct, right? So I will validate it. I'll modify the instructions, but you have the instructions now. All right, that makes sense? Go ahead and put this in the Lecture H Dropbox. Fill out a video review form, whichever you like to do, and, and go ahead and do the homework. Thanks.